with you here at D-Lab. This time I'm working on a Sansui model AU-G77XII integrated amplifier. This thing came in here with a common problem. It'll turn on, but the speaker protect relays don't engage, and therefore you get no sound. Normally, it's bad solder connections. Let's see if that's what it is this time. So here it is, the Sansui amplifier that's not working. Here's your inside shot. These are your final output transistors. And there are your speaker output relays, right? So when you turn on the power, normally, after about 10 seconds, you'd hear a click, right? And some amplifiers actually have a little LED that flashes that says power protect, but I don't see one on this amplifier. But either way, those two guys should be engaging, and they're not. So first thing I'll do is check these final output transistors, see if any of those are shorted. If not, we're going to go underside and take a look at the solder connections, because these things grow them, right? It's a circuit board, and here is your power supply section, and there's a lot of components here that generate heat, so they'll expand and contract over the years, causing these intermittent issues. Worst case scenario, if your protect relays won't come on after you applied power, it could be blown final output transistors, okay? So pretty much an easy way to determine that is look for shorts, right? So this meter is set up on diode check, so if something were to short, you'd see that, okay? Now if you look down at the base of these transistors, it does have the B, C, E marked on here, right? So if I go from base to collector, there's my forward bias junction, 0.5 volts good, 0.5 volts good, right? And then I always just go from the collector to emitter to make sure there's no direct short. So that one's okay. The same type transistor is over here on this channel. Same deal. They look good. There's no shorts. The two middle ones are the opposite polarity, right? So flip my leads, put the positive on the base. There's the emitter, collector, and across those, no shorts. So far, so good, right? Last one. Looks great. So it appears as though the finals are okay. And that is what usually would fail putting DC voltage on the speaker output jacks. These relays would say, hey, you don't want to throw DC on your speakers or you'll melt them down, right? So that's the purpose of those relays. It appears as though the worst case scenario is not the problem. So I'm going to go back to my original thought of bad solder connections. So let's pull the bottom off and inspect the board. So luckily, the bottom panel with a few screws comes right off of this thing. Had this been one of these newer style amplifiers where you can't get the bottom off, you got to gut everything from the top, I would not even have taken this on. But the guy was cool. It's a vintage piece, so I thought, what the heck, I'll give it an inspection. If I spot something, can solder it up, off you go, good deal. If it's anything beyond that, I'll quit. So I pretty much take my magnifying glass light here, and I'm going to very closely inspect this circuit board, looking for overheated areas and especially cracked solder connections. Right off the bat, I'm seeing a whole bunch of them. The driver transistors going to the outputs have cracks on all three leads. And there's some areas up here in the middle of the board. There's obviously a heated type component here, like a resistor, something that draws some current. I'm seeing some cracks there. I'm now looking at the power supply area, and there's a few bad connections, but nothing compared to what I'm seeing on the amplifier board. So I'm going to take the camera and we'll go through the magnifying glass and maybe you guys can see what I'm seeing. Alright, so for the fun of it, let's see if this camera can show you what I'm seeing. Alright, so I'll try to zoom in here carefully. Hopefully the focus stays good. But if you look at these connections, right there and right there, there's cracks around those leads. Okay, try to zoom in a little bit more. Need to find a better way of doing this. Okay, anyway, there's definite cracks around those leads. I'm going to get this thing out of the way. See if I can show you some direct connections here that I spotted. Right there are the driver transistors right there. And if you look carefully, you can see a crack. There's a ring right around that guy. Okay, so he's bad. If you zing over here to the other driver, same deal. You see those cracks? That's like bad news. Alright, now if you take a look in this area, you can see there's a lot of heating of components, and there's a whole slew of bad connections, right? So I need to touch up all these connections. Obviously need to touch up the driver connections, and I bet you that this amp will come back to life. Here we go. Obviously a word of caution, make sure that the thing's not plugged in while you're in here soldering. Alright, and the other thing is, take a meter and take some checks around the board to make sure there's no voltage, any residual voltage like a capacitor that's charged that could give you a little surprise. So what I do, especially on these cracked connections that look kind of gray and pitted, I take a little bit of solder wick and I remove some of that old solder. Okay? Now, you really don't have to do this, but I find that my new solder will get in there and do a better job if some of that old crap's out of the way. Okay? It's funny, I used to work on a lot of these receivers when I was in the Air Force. I had kind of an audio service center in the dorms. I always ran Marantz equipment, and guys would bring me their Pioneers, and of course these type of receivers and amplifiers that I would nickname Sansui. They didn't really appreciate that too much, but that was just part of how D-Lab operated back then, right? So anyway, after you trying to open up this can of alcohol, after you solder, you're going to see some rosin. You really want to take some alcohol and clean that rosin off the board the best you can, okay? And you're always best to clean it off immediately after soldering, because the longer that stuff's on there, it'll start hardening. Okay, so I take a little toothpick, kind of clean her up, take a little Q-tip. Now you see this connection here, hopefully you can see it. This is old rosin. It's been there since probably the day they built this thing. Okay, and you can see it's all dry and crunchy. What I don't like about old rosin is it will actually, you know, cause a path of high resistance, because over the years it'll absorb moisture and become a little problem child. So I always take a little extra time, clean it up when I'm done, and that's just part of doing a quality job when you're working on somebody's instrument. Alright, I'm going to go through and solder up some more of this stuff, and then we'll test it. So right in the middle of the board here, you see this ground runner going down. There's about 6 terrible connections. Now I'm going to solder these, and then we'll go top side and try to determine what that component was. But it sure looks like it's taken some abuse over the years. But yeah, there's some terrible ring connections. Now see how I tried to solder that? And you see that the solder just kind of moved to the side. There's a little hole there, right? That's why I use this wick. Take that off of there. Go back in there, resolder that guy. Boom, perfect, right? So that's the value of removing some of that old solder. So, you know, don't get in a hurry. Take your time, because you really only want to do this once. You don't want to keep coming back in here and saying, oh, I missed another one, right? Anyway, we'll cut back to this after I've taken care of some more bad connections. Alright, almost done. I'm just cleaning off some of this rosin. A lot of excessive rosin in here. When you're in here scraping off this stuff, I suggest that you use a toothpick. Okay? Don't get in here with a metal tool, because you can obviously damage the foils, and if you're not careful, you could generate like a short circuit in here, right? The other thing that you want to do is really take some time and inspect your work. Get that magnifying glass down there, right? Take a really good look, because if you cause a solder bridge on a solid state component, it's just going to burn the amp up. And remember, it goes at the speed of light. You can't move fast enough to stop it when it's happening. Alright, so I probably hit about 150 bad connections. Most of them centralized in this middle area. Remember I told you about those leads that I saw about in the center? They're all cracked. Well, that would be these 3 watt resistors and these filter caps, right? So that would obviously cause some big problems if those are power supplies going to the outputs, right? I don't have the schematic right here, so I'm really not going to verify it. But the main violators that I saw were these driver transistor leads where they went into the board. Now if you envision, you've got this hard mount, right? You've got this aluminum heat sink, and then these parts are soldered into the board. So what's going to happen when the board's doing this from vibration and wear and tear over the years? Yeah, it's going to crack the leads because there's no give, right? This is a hard mount. So if this were to move at all, it eventually is going to fatigue these solder connections. And hopefully that's what it was that was causing this issue. The only way to find out is to power it up and see if these relays pull in. Alright, here we go. Maiden flight after all the bad solder connections have been repaired. We're unplugged right now. Volume's all the way down. Now remember, I don't stage this stuff. You guys are going to see it as it happens. So if smoke comes flying out, hey, I guess you're going to get a show. Here we go. Okay, relays are not pulling in. So either I missed some connections, or we still got an issue with the amp. Bummer. Alright, flip this guy up on its side so that I can check some voltages. Okay, so you've got your 2 final output transistors, and in between them is what's called the emitter resistor, and that's where these 2 transistors meet, let's say. Okay, and at that center point, which is right there and right there, you should have 0 volts or close to it, right? Because that is what goes to those speaker output relays. So if we have DC voltage there, that could be cause of the problem. So let's turn it on. I'm going to get right, whoop. I just heard those relays click. But either way, I'm going to check this. So you got to be very cautious when you're in here. So I have 0.002 volts. Of course, you can't see my meter, can you? That's what happens when you're a one-man show here. You got to be very careful. Okay, it's right there. 0.02. What do we got over here? 0.36. So this channel is still causing a slight offset, which is probably causing the intermittent operation now of the speaker output relay. So I'm going to take another look in this area for bad connections. And I'm also going to inspect components, see if there's anything overheated. But the amplifier now is trying to work, so that's a good sign. Alright, so I did find some more poor connections in this area. So let's recheck the emitter resistor value. Like I say, you got to be super duper careful, because if you slip like I just did and you hit something while this thing's energized, it'll blow the finals, and then you're going to be bummed out seriously. Okay, so here's this side, we're at 0.02 volts. Here's this side, we're at 0.03. So it appears as though the old Sansui is good to go. So next, let's get it on a dummy load Let's throw some audio through it, look at it on the scope, and make sure it has a nice pretty signal. And then after all this, I think D-Lab is in line for a reward. Alright, it's final checkout time. So to perform this task, I'm going to utilize the D-Lab stereo dummy load test set. I haven't used this thing in a long time. So what this does, it's got built-in dummy loads that are for each channel, and then you have these outputs here that go over to the scope. And then to test it, I use a CD player, but the CD player has a special CD in it. I bought this years ago, and this thing actually puts out test tones. So like the first track is 1 kilohertz for like 10 minutes, right? And then it goes through all these other frequency steps. It's a great way to have a signal source for checking amplifiers if you don't have an audio generator. You can use your CD and that CD player, and bam, there you go, right? So here we go. I'm going to turn it down, power it up. We're on CD input, CD player, of course. We'll hit play. Bring her up, you can see the bar graphs doing their thing, which is cool. Let's take a look at the audio test set. There's the outputs, right? They look fairly equal. But the true test is, what does the scope see? There's the 2 channels. Need to turn my amplitude up a little bit. Yep, she's a-working. They're looking very clean. So far so good. Looks like the old Sansui will live again. This guy's going to be super happy. So back in the early days, when D-Lab was first started, I did a lot of solid state repair. Used to do a lot of receivers, amplifiers, worked on some of the real cool ones, like Sound Craftsman, old Macintosh, fun stuff. But then I got into tube amps, and I enjoy working on that a little bit more now because I'm getting older, so it's kind of hard to see. Anyway, this was a successful repair, and what should D-Lab get after doing such a repair? Oh, well, of course, a glass of wine. Anyway, it's a great repair, and I'm very happy that it turned out as well as it did. I had my reservations about doing it. D-Lab doesn't mind doing solid state repair, but I'll stick to the tube stuff. We'll see you again.